So for the sake of time, I propose we move on because I'm trying to snatch a few minutes away from everyone. So thank you so much, Anna. And I propose we now move to Bertrand Pavageau from Solvay. So Bertrand started at Solvay in France in 1905 on advanced radical polymer synthesis. That speaks to me because I also studied polymer science. And then in 2005, he moved to Bordeaux, which is a nice place to be in the Bordeaux laboratory of the future. And back, I would say, to Solvay Corporate Affairs R&D in 2010. And since this year is part of the Solvay Green Hydrogen Platform, GHP as they call it, as a program manager to sponsor and feed the pipeline of innovation and also in charge of the external partnerships. So we're happy to have you, Bertrand, and please go ahead.
Okay, thank you for the introduction and for the organizer to give us the opportunity to introduce our activity in hydrogen. So before starting in hydrogen details, few words about our company. So we are, I would say, a multinational company in the field of material, product, and chemistry, strongly committed in the field of science. I would say developing product all over more than 60 countries, operating more than 100 industrial sites all over the world with more than 20,000 employees, with a net sale around 9 billion euros for the 2020 figures. Regarding our presence all over the world, we have, I would say, well-balanced presence with, I would say, 1/3 activity in Americas, 1/3 in Europe, and 1/3 in Asia Pacific area. Today, Solvay is organized in these three business segments. So the material segment is clearly, I would say, the growth engine of the group, combining our specialty polymers portfolio and also our composite material portfolio to serve mainly sustainable mobility application regarding lightweighting, but also electrification and other activities around IoT and digitalization. The chemical segment is dedicated to, I would say, the commodity material that we have on the group, but require, I would say, specialty processes to produce, I would say, the right quality needed for our customer, where we find our soda ash activities, peroxide, silica, and Coatis. And the next segment is a solution, is more dedicated to our specialty chemicals, mineral chemistry, formulation, where we serve markets such as agrochemicals, foods, consumer goods, mining operation, and electronics. So what does it mean, clean hydrogen platform within Solvay? And I have this very basic flowchart to explain that. So a platform within Solvay, it's a transversal organization, market and business driven organization. And as you can see, it's connected to the highest level of the group, the reporting to our CEO, Ilham Kadri. And this is the third platform that we have recently setting within Solvay. So we are acting as an internal joint venture within the group, with the head of the technology, head of commercial and business development and marketing. And it offers to us to be connected to all the product and technology. As I showed you before, we have the capability to activate in order to serve this hydrogen economy. So this is this great advantage to have this transversal organization. And our perimeter on this platform, we are proposing and developing product and technology to serve, I would say, all the hydrogen value chain from the production phase. For example, we have our ionomer, proton exchange ionomer membrane that can be used for the redox flow battery to buffer the renewable production. Same ionomer family that we can find on electrolyzer for PEM electrolyzer, but also other material that can serve for what we call the balance of stack. And we can find the same, I would say, mirror material in the fuel cell. We are talking about the same family regarding the proton exchange membrane and the balance of stack. And we have also, thanks to our soda ash activity, we are proprietary of salt mine for cavity storage. And thanks to our material business segment, we have also a large portfolio of material that can serve hydrogen tanks, pipes, to manage all the logistical aspect of the hydrogen in this value chain. And regarding the end use, beyond the stack, we also have, and it is already connected to our historical business in the mobility, other material that we can propose to be part also in this, I would say, mobility transformation to follow this hydrogen development. And in order to go in a bit more detail, but thanks for my colleague from ACFA to have already presented the different electrolysis technology. It's just to give you a flavor of what our material is acting in these different technologies. So the alkaline aqueous electrolysis, we have this kind of polymers that is a part of the diaphragm that is used for this electrolysis. As I already told you, we have this proton exchange ionomer that we have developed more than 20 years ago within Solvay in Italy. The Aquivion trademark that is used for the PEM proton exchange electrolysis, but also for the PEM fuel cell, as I told you before. And also, thanks to our specialty chemicals business unit, we have also an activity on rare earth material. And we have also developed this cerium-based compound as electrolyte and electrodes for this high temperature electrolysis, solid oxide electrolysis. And regarding for the end use, as we also investigating hydrogen tanks, thanks to our thermoset and thermoplastic composite portfolio that can be used for the different type of reservoir for mobility. And as I said, for the stack, and this is the zoom in of the fuel cell stack. In the center, we indeed find again our ionomer, proton exchange ionomer. But as you can see, we have also plenty other polymer, specialty polymer material that can serve regarding sub-gasket, bipolar plate, or also end plate to serve this market. And this is all for me, and thanks for your attention.
Thank you, Bertrand. It was to the point, and it enabled to save us a few minutes, so everyone is very grateful for that.
You're welcome.